Hey everyone, my name's Ritesh, and welcome to the Intro to Artificial Intelligence video. This was originally a camp, but due to technical issues we had to make it into a full-on video, and so that's what it is. So let's get ready and get into it. So who are we? STEMpump is a student-led initiative that teaches students the best of STEM technologies for free. We cover everything, from programming, robotics, even game design. The reason this video and these camps that we've been hosting came out is because during the quarantine we wanted to give back to the community by teaching some free, different types of STEM skills, whether it be, robotics-based, programming, or like I said, game design. And so here's some topics we're going to be going over in this video. We're going to be talking about the basics of Python, what is artificial intelligence, machine learning basics, we're going to look into things like Google's Teachable Machine, and then an intro to TensorFlow. So what are we doing? In the video, we're going to be learning a lot in this short period of time, and so the main part of this video is understanding how machine learning and artificial intelligence work, and then making a model yourself. Due to the complexity of this video, it's going to go by very quickly, and so you got to make sure you pay attention at the small parts or you can fall behind. The best part is that you can always, go back in time during the video and just check what's going on. Like always, feel free to contact us via our website or social media accounts if you have any questions. We're free to answer them all the time. And so we're going to start off with the basics of Python first. And so before we even go into Python, we have to talk about what is programming. And so programming is the art of giving computers instructions. One language for this is Python. Programming is used to program your computer, appliances, even your electric toothbrush. It's really used everywhere. So types of programming languages. These languages actually allow us to send instructions to computers. So whether your phone, an actual computer, your smart fridge, programming languages allow us to bridge the gap between computers and people. For example, Java, Python, C++, and Swift. These are just some examples of programming languages used for a variety of purposes. Syntax is the grammar of what programming languages use, and it's the set of rules that we need to follow in writing our code to make sure that our computer, when it runs the code, understands what we give it. And programming languages have all different types of syntax, and Python has a pretty unique one too, so we're going to be going over that. So first, go to stempump.com/r/editor. So we're going to be talking about our environment, and so today we're going to be working with our online code compiler called REPL.it, or it. When developing programs in the real world, like in a job or just in any real circumstance, most of the time you're going to have to download Python in an IDE to get your work done. And an IDE stands for Integrated Development Environment, and it's basically a tool or program that allows you to basically program. It gives you a variety more options, more power than these online tools will give you. Today we're also going to be using a tool called Google Collaboratory, which will allow us to run our program, share it, do all sorts of cool things without the need of powerful hardware. Because when you're doing a lot of machine learning, you either need to have a lot of powerful hardware on hand or have a lot of remote powerful hardware, and that's what we're being using is the remote variant. And so first, you got to understand what variables and data types are. So a variable can be compared to a container. It has a name and a value. We have this box right here. It's empty. So we can apply a name to this box. We can call it white box. But there's nothing in it, so we just, maybe number of items in it is nothing. So we would say items in white box equals 0. And so that's kind of an example of our integer. An int is an integer number. So basically it can be a negative whole number or positive whole number. A float, which these are all our data types, a float is basically a decimal number. So if it has decimal in it, it's considered a float or floating point value. And then we have str, which stands for string, which is basically going to be a text, so not really numbers. And let's experiment with that right here. So in Python, when you want to create a variable, all you really have to do is write the name of what you want it to be. So I can write donuts equals 7. And then that's my variable. I created donuts equals 7. I can write name equals Greg. That's another variable. This one's a string, you can see because I have quotes around it, and this one's an int because it's a whole number, and then I can write pi equals 3.14, and this would be a floating point or float value. And if I run the code, we're not going to see anything come up here. Because in order to do that, we're going to actually have to print it. And so the cool thing about it is if we just want to print it, all you have to write is print, and you can hit enter, and then add 2 parentheses, right here and here. And then the cool thing with REPL is it will show you what you need to add. So right here it says value. So if I write donuts, I can hit run, and it prints out 7, which is number of donuts. If I replace this with name, and I hit run, we can see the word Greg. And if I type in the word pie, and hit run, 3.14. And so you can really experiment with this by typing, different types of numbers, all that. The cool thing about it is Python's considered a type-safe language, which basically means is that it'll auto-know what you're typing in, which is why we don't have to tell it, this is an int, this is a string, this is a float. It automatically knows based on the value we give it. And right here for print, it'll print it directly onto this side. In Python, we can also use basic math operations with the following symbols. We can use addition, subtraction, multiplication, and division for starters. So if I had my number of donuts, right, I print it, run, 7, but I wanted 2 boxes of donuts. I can put this little asterisk, which is for multiplication, hit 2, and I'll get 14, because 7 times 2 equals 14. I can also, maybe add 2 maybe make this a baker's dozen, or just a normal dozen, I don't know. I'll make a normal dozen. Adding 5, and you can see 12. But what if I just want to have, donuts? I can add 5 right here. And I run it, it's still 12, because the math is happening here, not happening here. So we have this. And we can also, take donuts, maybe we ate a few, and subtract 10 from it. We have 2 donuts. Or maybe I have 3.14, and I wanted to divide it by 5. I can hit run, and it will show me that exact answer, which is pretty cool. So you can do all these different types of math type, equations in here. But if I wanted to, do name plus 10, I'm making an error because you can't add this number to a string. It's a piece of text, and we can actually. We're going to talk about it in a little bit on how we can, add them in multiple of the same line, so we can show multiple variables in the same line. So right here we have print, and like I said, print is the statement/code we're going to be using to make numbers, text, variable values, or a combination of the 3 show up in the console. And so you can see if we typed print 1 and print high, you would get 1 and high, and you can also do it like this. Concatenation. So concatenation is basically us putting things together. So in Python, you can put strings, which are basically text, together with the plus sign, just like this. And so if I wanted to write name ate the cheese, even though he wants to rally do it, I hit run, you'll see that, I forgot a space right there. You'll see that it combines the 2 phrases together. So I can rename this to Rally ate the cheese, and it changes right here. So what if I wanted to say Rally ate 12 donuts? So I could write name plus space 8 plus donuts. Space right there. And then, actually make that nicer, donuts. And if I hit run, we're going to see we're going to get an error right here. And the issue is that this is a string, name is a string, 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 but this is an int value. It's an integer. So what I can do is I can write str, which stands for string, and put that like this, and hit run. And what this does is it converts donuts into a string right here. However, it doesn't mean that we still can't, add. So I can add 10 to it, and he ate 22 donuts, which is a lot of donuts. Next, let's go over lists. If you want to learn more about Python, feel free to watch our Python video, also on the YouTube channel, or read our Python course. And I'll explain how to do that near the end of the video. So let's talk about lists. Lists are a form of organization in most programming languages. They allow you to store multiple pieces of information in a single array, is what it's called. So we have 2 types right here. We have one type. We have my list, and it's filled with a string, a integer, a float because of the decimal point, another string, another int, and a floating point. So I can recreate that. So let me just write my list. And the way you create it is by doing these little square brackets. and let's just create it. So text 1, 2, 3.09, text 4, 5, 6, and hit run. Nothing changes. But what if I want to print out, a certain value from here? So the way this happens is lists number each one of the items in it, and we can separate these items with these commas. And so how it orders them is from 0, it starts at 0. So text 1 would have an index, is what it's called, of 0, which means the second value would have an index of 1, 2, 3, 4, 5. So then if I write print my underscore list, and then I put my square brackets again, and I put 0, and I run it, it's going to print out this first value because this has an index of 0. But what if I want to print, this value, right? I can just type in 5. And it would print out 6.0. So that's basically how lists work. We can put a list of items together, and so they're kind of grouped in there. So a bunch of variables are grouped. What if I put name here? And yeah, we can even put other variables into our array, or our list, and then we can be able to print them. And so like I just said, we can access specific list items by using their index number. An index number starts at 0. And so right here, they used my list 3. If I did that, run, we would get text 4, because 0, 1, 2, 3, and that corresponds with the index value. So now we can talk about for loops. And so what a for loop does is it allows us to loop through an item a set number of times. So when we're working with our machine learning code, we're actually using a for loop in one instance. But we wanted to do it the number of times for a list. So we can do something called the for loop on a list. So it'll allow us to write for item name and list name code to run. And we can assign any one of these, items that we want and refer to it in the code. So an example of this would be if we have a list like this, we can say for I in my list, print I. And so what does the I mean? Well, the I is just a random variable that we created that represents each one of these items. Right here. Actually copy that code in. So if I write for I, you can write anything. You can write item, we can write A, we can write B, you can write any word. Let's just write I. For I in my list, and then we're gonna add a colon. We're gonna hit enter, and what you're gonna do is you're gonna hit tab. So in Python, when you want to show that code is being inside another item, we're gonna use tab in order to show that this code goes underneath, because we don't want to print randomly. So then we write print I, and watch what happens. If we run it, it printed out every item of our array. But if I didn't add that tab and I hit run, it's gonna crash because we need indentation, which is the tab. So by indenting it, we basically say, okay, we open a for loop, we open it, and inside the loop, I want you to print I. And so we write I, right? I just means each item in the list. I can change that to, spaghetti. For spaghetti in list, print spaghetti. And the same thing would happen. It would just show it, because this is just representing the name of what we want to call each one of these. And so that's basically our intro to Python, right? So from here, you can either, go to our Python course or watch a video and kind of dive more deep. But right now, we're going to be actually going into artificial intelligence aspect of the video. So what is AI, or artificial intelligence? Artificial intelligence is a wide-ranging branch of computer science concerned with building smart machines capable of performing tasks that typically require human intelligence. And so let's look at some examples of what AI is, right? We have Siri. Siri is considered AI. Siri is basically a voice assistant that helps you, go apps, find information, text, call, do a lot of different things. We have Ultron, the evil, villain from Avengers, Marvel, all that. He's an AI. We have Tesla's autopilot, and this basically allows Tesla cars to drive by themselves based on, camera information and sensors that you can see all right here. This is kind of what the cars are seeing. This is, AI. Then we have C-3PO and R2-D2 from Star Wars. They're both AI. And so there's two main types of AI. We have ANI and AGI. We have artificial narrow intelligence. AI that is as good as human intelligence at only one thing. And we have tons of ANI, and we're going to go over what they are in our real world. And then we have AGI, which is artificial general intelligence. And that's AI that is as good as human intelligence at everything. And right now, this doesn't exist. It might not ever exist, but it currently exists only in pop culture. So let's go back looking at our examples we just talked about. Let's classify the examples. We have Siri. Siri is considered ANI because Siri is a voice assistant. That's the only thing it's really good at, is telling us information. It can't, think for itself or, get up, drive a car, pick up the mail. It can't do those things. So it's considered ANI. It's narrow. It can only do really one thing, which is assisting you. We have Ultron. Ultron is AGI. It can think for itself. It can move. It can do anything a human can, and maybe even more. We have Tesla Autopilot, which is ANI. It's only designed to make sure your car, drives by itself and monitor all these different obstacles in its way. It can't, start cooking your coffee, making your coffee for you, or, do what Siri does or do what Ultra does. It's always designed for one narrow, specific item. And then, as you assume, C3PO and R2-D2 are both AGI because they can do everything a human can do up to a certain extent, more so C3PO than R2-D2. And so how does artificial intelligence learn? Because it has to learn, right? It's artificial. It's not real. How does it learn to do things? So artificial intelligence learns through repetition and examples. It's going to repeat these examples many times, creating or learning rules from the data that it's given. The best AI has the best data because AI is only as good as the data it is given to learn from. If it has bad data it's given, it's going to learn poorly, meaning that it won't be smart. So let's actually talk about a very simple AI. Google's Teachable Machine is a really great non-code solution that we can use to really see what AI is possible of. So you can go to stempump.com/r/TE-Google and it'll bring you to this page, Teachable Machine. So it allows us to train a computer to recognize, images, sounds, or poses. You can really choose, and it's very, adaptive. There's the TensorFlow logo right there. And so you can hit Get Started, and then we can get started with that. Along with this, I want to say go to stempump.com/r/cats/dogs. To test Teachable Machine, we're actually going to give it some dog images and some cat images. And then from there, it will determine what a cat or a dog is. And so Microsoft actually already did this. They made a Dataset, which is basically a folder filled with thousands and thousands of photos of different dogs and cats for us to train our models. So, like I said, you want to go to the website. We're going to click on Image Project right here. You're going to hit Image Project, and then you're going to hit Upload. And what you're going to do is you're going to upload, one group of dogs and one group of cats. I'm going to show you that in a little bit. You just got to click Train Model. We're going to talk about these advanced items in a little bit, and then you can upload your own images. So what I have right here is I did that. So what happens is when you open this, we can hit Get Started, Image Project, you're going to get two different classes or groups. And so I just named my first one, dog, my second one, cat, and then right here I uploaded 20 pictures of dogs and 24 pictures of cats. You can upload as many as you want. I just kept it small so I wouldn't have to overload the browser or anything like that. And then you just have to hit this button that says, Train Model, and it's going to, time it, and it's going to train itself. And so what I'm going to do is I'm going to upload a file. It's kind of glitchy there. Choose files. There. I'm just going to upload this thing. So that was when I already trained. I can just go here. And so you can see 98% thinks that it's a cat, but 2% thinks that's a dog. And so that's because I fed it a very small sample. It needs more samples to really learn. But as I showed you, if I put some cats into this, it would definitely think it was a lot more dog than cat. Because what it's doing is it's trying to learn the rules or learn why a dog is a dog and why a cat is a cat. If you look into this advanced settings, we see things called epochs, batch size, and learning rate. And like I said, we're going to be talking about these few things here. But I really encourage you to, use Teachable Machine to really learn how AI works, because you can do an image project, so maybe add more animals. You can add tons and tons of classes and create a pretty sophisticated AI, without any code, just basic testing, learning how it works. You can do audio projects, so use your microphone or files, and it would determine sound. Or you can use pose, so you can do different types of poses, and it would learn which pose is what. If there's a punch, if there's a kick, a jumping jack, all these different types of things. So if you don't really want to experiment with code and just kind of see how AI works in general, this is a really great way to do so. So let's talk about machine learning. What is machine learning? Machine learning is the study of computer algorithms that improve automatically through experience. We know that AI learns through repetitive training and good data sets. Like I said, AI is only as good as the data that we give it. So if we give it bad data, it's bad. If we give it good data, it's good. So it has to learn through good data sets and train itself. So we're going to be creating a model, which is a file that's been trained to recognize certain patterns. We're going to train this model using data, providing it an algorithm it can use to learn from the data. So simply, the model is going to take pairs of inputs and outputs to figure out the algorithm or the rules to what we're going to give it. We're going to be using something called TensorFlow and supervised machine learning. So what is TensorFlow? TensorFlow is an open source artificial intelligence library that allows us to use data flow graphs to build models. That really sounds like a mouthful, right? But basically, all you need to know is it's a way for us to program AI using machine learning, which I just explained what it was. And so it's a really great thing that Google has made, which is a library, and we can use information from this library. And so we talked about using supervised and unsupervised learning. We're going to be going over supervised learning today, but I'll explain what unsupervised is. So in supervised learning, the algorithm learns on a labeled data set. So we give it, inputs and a provided output, right? So what happens is, if it makes a guess, right? If it says cat or dog, and it makes a guess of dog, we have an answer key to that. So it does get it right, it'll know that's correct. But say it sees a dog and it calls it a cat. Well, we can tell it, no, that was a dog. And then it will learn based on this, and it can evaluate its accuracy. In unsupervised learning, the algorithm tries to learn by figuring out the patterns itself. It's not given a rule book. It's not given, answer key. It just has to try and figure it out based on lots of learning. So today we're going to be doing a supervised learning system. And we're going to be using TensorFlow to predict Celsius to Fahrenheit conversion. Well, isn't there already a formula for that? And yeah, there is. But that's exactly what our model's going to be trying to find. It's going to be trying to figure out this 1.8 and this 32 if we only give it C and F. We're going to be feeding in some values. Like I said, we're going to be feeding in C and F, and it has to figure out what 1.8 and 32 are via training. So this is the really cool part. We're giving it the input value and the output. And it has to learn how it can turn the input into an output. So we're going to be using this thing called Collaboratory, which is Google's free cloud Python editor, which is suited for machine learning, data analysis, and education. And like I said at the beginning, it removes the need to have a powerful machine for artificial intelligence and machine learning work. So if you go there, you're going to see a page just like this. This is the basic Collaboratory page. Now you're going to want to hit New Notebook. Right here is what our notebook looks like. So let's kind of go over the key components of this. This is the name of the file, so you can name this really whatever you want. This is called a code cell. We're going to be putting different parts of codes into different cells so we can create, a more linear structure and kind of separate and organize our code out. This is how you run code cells. The cool thing about a notebook is you can run individual parts of your code without running the entire file, like in most cases. So this might be helpful if you want to have multiple versions of code and you want to try each one at different times. It's also good for staggering out which code is run. To add a new code cell, you just have to hit this add code or plus code button. And then there's this add new text cell, which basically adds a text version. And this is really good. It's meant for reference and ignored, and it's better than adding comments, which if you know in Python, allow you to write down information that you can read. And so text basically is really great for if you want to share these collaboratory notebooks with other people and show them what your thinking was, your notes and stuff like that. Right here is our connection status to Google's hardware, which is, you can access via internet or Wi-Fi. And so you'll be able to check your connection to that. Right here we have runtime. Basically this controls how we run. And so the main thing we're going to be using is run all, which allows us to run all the code at once rather than individually clicking these little run buttons. And so you can go here. I'll just open my new notebook. And while that's loading, I'm going to keep on going. And so like I said, you might have not seen this type of file before. It's called a Jupyter Notebook, which is super helpful for breaking up Python code. This code can be run in different orders, have text for comments or context, and more. And why do people like this over, normal files and stuff? Well, it allows data scientists to streamline their work, increase productivity, as well as improve collaboration efforts. Before we get started, it's important that we understand what we're going to do before we do it. Otherwise, you're just going to be blindly following me, and that's not good. It's great to understand what you're doing before you do it, and also reduces how confused you might be. So first, libraries. A Python library is a collection of functions and methods that allow us to perform many actions without writing our codes. Functions and methods are basically ways that we can use large portions of code in less space. So we might make a function to add 1 to a number in a normal case. So we can just write add 1 and it would do that. So like I said, there's a whole Python course and video available if you want to dive into this a lot more. However, we're not going to be really doing that, so all you have to really know is that it simplifies our code, but we can also use libraries to give us these functions, which makes our life a lot easier. So these are the libraries we're going to be importing. We're going to be importing the TensorFlow library, so we can use TensorFlow. We're going to be importing something called NumPy, which allows us to use data as lists. We talked about lists. NumPy will allow us to create more advanced types of lists that we can use with machine learning. We're going to be using something called logging, which is just to display errors in our code for TensorFlow, and something called matplotlib. And we're going to be going over that later. We're using a very small data set, so there's not that much training needed for our formula to be found. So we can go over some terminology first. First, a feature. A feature is the inputs to our model. In this model, our features are the degrees in Celsius. The labels are the output we want our model to predict. We also give these during our example in our training phase. In this model, it's going to be degrees in Fahrenheit. And then we have something called an example. So an example is a pair of features and labels which are used during training. So in this case, our first part of our example would be Celsius, and our second would be a Fahrenheit value. A feature and a label create an example. A neural network is a set of algorithms modeled loosely after the human brain that are designed to recognize patterns, which is why it's called a neural network, based on neurons in your brain that kind of think. A layer is the highest level building block. It's going to allow us to take in inputs, transform them, and pass to the next layer. We're only going to be working with one layer today, so it's not as complex as we need it to be. A neuron is, in a neural network, a neuron is a mathematical function that model the function of a biological neuron in your brain. What it does is it transforms our inputs. So in our layer, we have neurons that convert our inputs into outputs. And you can see right here. So we have an input layer where we feed in inputs. We have a main layer or a hidden layer which transforms these inputs and create an output. And so in here, these would be our neurons, these would be our inputs and our outputs. And so this one has 4 neurons on this layer. But what you can do is when you go into really complex and deep neural networks, you might have tons and tons of layers of neurons all working together to convert one thing to another. So now we're going to create our model. We're only going to be going over the basics and scratch the surface, so you might have a lot of questions, but don't worry. We're going to be creating something called a dense network model, which is the simplest model to make. The formula is very straightforward for converting Celsius to Fahrenheit, so we only need to create one layer with one neuron. It's going to be called a sequential model, which is very linear. So we only have one. A sequential means we basically stack layers on top of each other, but we only have one. Inside TensorFlow, we're using something called the Keras library for all of our dense layers, and it makes it a lot easier. we're going to be creating a layer with a shape of 1. And so you really have to kind of visualize how it would look. And so a shape of 1 basically means it's a one-dimensional array with only one member, which would be our neuron. Since we only have one layer, the shape of the layer is the overall shape of our model. And so when we say shapes, we're talking about the complexity of our model. We're only going to be creating a single floating point value, which is our Celsius value. We're also using one neuron, which is the size of our model's output. A single floating value, which is our Fahrenheit degree value. We fed in a Celsius, and we get back a Fahrenheit. And so when we're done with this, we can assemble our layers into a model and compile it. And so when we compile our model, we get two things. We use something called a loss function. And what this tells us is it's a measurement of how far our predictions are from the outcome we want. The difference between our predicted and our desired value is called loss. So it's basically how wrong it was, right? And so the reason we need to know this is so the model can say, oh, I was this far away from the actual value. Let me try doing something a little bit different to see if I can get closer. And what it does is it tries to go back and forth over and over, try to get closer to the actual value. But how does it go and decrease our loss? Because we need to get as close as possible. And we use something called an optimizer function, which is a way to adjust internal values to decrease loss. So the type of optimizer algorithm we're going to be using is called ATOM, which works perfect for our network. And like I said, we're going to be going over a lot of things that you might not understand that will require a little bit more, research into. So during the training, we're going to use both the loss and optimizer functions to calculate our loss at each training point to improve it. Training is basically calculating our loss, or how wrong we are, and then trying to improve it using our optimizer function. The optimizer function is used to adjust internal variables of the model. The goal is to adjust these variables until a model, which is actually just a math function, so doing a lot of transforming using math, reflects the Celsius to Fahrenheit formula. Both the loss function and optimizer functions are used in simple models, but there are lots available when you're working with a lot more complex variables and models. One thing we need to consider is something called the learning rate, which is called 0.1. Which is we're going to be using 0.1 for. And so what the learning rate is it's the value of adjustment that the value uses. So when we have a small learning rate, it takes a lot of iterations to train. When we have a large learning rate, it's going to create low accuracy because the differences, the adjustment value will be too high that it will never be able to narrow down. To find a good learning rate, you really need to test random numbers, but between 0.001 and 0.1 is a really good area. So that would be something to look in for to try and find that perfect area or perfect value. So now we're going to actually train our model. During this time, we're going to input Celsius values. It's going to perform calculations and then output our Fahrenheit values. The weights start off randomly, so the output is not correct. So being random, it's just going to throw a number randomly as a weight, and then the loss function will calculate the difference between this output and the output we want. The optimizer function will then use this value to determine how to change the weights. And so the weights are the internal variables, which are calculations that it's using to affect the input. And so to control our training cycle, we're going to be using something called the fit method. So what this does is it allows us to feed in our examples something called cycle count and how much output we want. We already saw this term before, epochs. Epochs are basically our cycle count, or how many times we want them to go through the examples. We're only going to be giving them a few examples, so the more the machine learning program can run through the examples, the better. And so when you run longer, you're basically training it down to the most precise detail. And then verbose, which is how much output we produce. If verbose is true, it will show us a very visual representation of the loss value and how it's thinking, or it's false, we can hide it. So we'll show you how to do that. And then after this, we're going to be getting something called a history object. We won't talk about objects that much, and you can see our Python course for more, as I've said many times. What we can do is we can use this history object and generate a curve. So a graph that will show us our loss decreasing over time. I mentioned Matplotlib, and this is a library which allows us to visualize our loss magnitude over epoch time. So it's a plotting library which allows us to plot our data. Our goal is to have the lowest loss possible, which shows that we have low variation from our predicted Fahrenheit value. So now let's actually program our model. So if we have our collab right here, our notebook, let's just type in some few things. So first I'm going to write import TensorFlow. And I'm just going to write as TF. So rather than writing the word TensorFlow, I can just write the word TF. That's going to be my first block. And my second block, I'm going to write import numpy or numpy as NP. I'm also going to import logging. And so these are my first three libraries. This one's going to help us with creating those very complex and powerful lists. This one's going to help us with errors, and this is to control the overall machine learning program. So we're going to create a variable called logger, which is equal to tf.get_logger. And this is a method that will allow us to get the logger from tf. And then next what we're going to do is we're going to use logger dot set level, and we're going to feed in a value called logging.error from our logging library. So this is just going to get our basic errors set up. So if you have anything wrong, it'll allow us to see that. Now what we're going to do is we're going to set up an array of our information. So right here, I already kind of got this information. So we're going to create a variable called Celsius_Q and another variable called Fahrenheit_A. So if you do np.array, parentheses, and then we can put a list right inside there. So the reason, and then we're going to write dtype equal float. So it knows that the data type we're giving it is a float, even though it looks like an integer. The reason we're going to do this is because these are very complex types of lists that numpys allow us to use. So it will allow us, our machine learning program, to work really well together. Now we're actually going to write a for loop that will allow us to see this information. So I'm going to write for I, comma C in enumerate Celsius_Q. I'm going to add my colon, hit tab. I'm going to write print. I'm going to add my quotes. I'm going to add these curly braces right here, degrees Celsius. And don't worry, I'm going to explain what this means right after done writing it. Equals degrees Fahrenheit. Dot format C, comma, Fahrenheit _A _I. Okay, so what does this actually mean? So first, like I said, we have our two lists. The NumPy array just makes it more powerful. And so we already talked about how for loops work. So what are we doing right here? So enumerate, what it allows us to do is it allows us to get the item value, but also the index. So when we get -50, we also get 0. That way, we can use the 0 value from Fahrenheit. So if I run this, it's connecting right now. Okay, get connected. Oh, I forgot to import. Okay, yeah, you have to import all of them in a row, sorry. Okay, you can see this. -50 equals -58. And so this corresponds to this, because we're using this. If I just put 0 right here, and I reran, -58 would show everywhere. So what the I does is it allows us to get the index number from Celsius_Q, so we can correspond all these. So what do these curly braces mean? What this does is it basically says, okay, when we do dot format, when we add a value of C right here, it basically puts that C and concatenates it right here because of how, you know, this is a complex type of list, so it has a complex value, and so we don't really have to do any of those complex things. You just got to write dot format, and it goes directly into here. And so with the second one, it pulls from the second area. So I'm just going to hit runtime factory reset. Yes, just so it resets. Okay, I'm going to do another code block now. I'm going to name this layer 0. Okay, that's our variable name. It's going to be equal to tf.keras, which is our library for our dense layers, layers.dense. And so we're going to be using a dense layer. It's going to have one unit, and then input_shape of 1. And we're just going to put that as a list for now, because that's how it likes it. Then what we're going to do is add another code block right after. We're going to create a variable called model, which is equal to tf.keras.sequential. And like I said, this basically stacks it, but we only have one layer, which is layer 0. And it also wants it as a list, so I'm just going to write layer 0. Now we're going to add one more. And now this is where we're going to do compile, where we give it our loss and our optimizer functions. So I write model.compile loss equals, in single quotes, mean underscore squared error, which will be our type of loss, comma, optimizer equals tf.keras.optimizers.atom and 0.1. So this 0.1, remember, is our learning rate. So how much it's going to change the value based on what it does, or based on what it predicts, how it affects our internal weights, remember? So what this does is we're basically just setting our loss function and our optimizer function, as well as our learning rate for the optimizer function, which adjusts the internal weights. In this next code block, what we're going to do is we're actually going to now train the model. So we're going to create a variable called history equals model.fit. Remember we explained this. We're going to feed in our features and labels. We're going to give it our epoch value, so I'm just going to give it 1,000. And right now, we're going to set our verbose equals to true, so we can see the model training. And let's just print, some text saying, finished training the model. After this, we're going to add another code block. We're going to write import matplotlib as our .pyplot. So we grab a little part of it, the pyplot part of matplotlib as plt dot xlabel. So what's our x-axis going to be? And we're going to set it to, we're going to name it epoch number. So the label. Our y label is going to be called loss magnitude. So our loss value. And then we're going to plot. So dot plot, and we're going to use this history loss. So we're going to use this history. Remember, we train right here, so it gets a history object, and then we're going to use that to find our loss. So it's going to show that. And so if I run our code, hit run all. It's now going to run them one at a time. You'll see it's reconnecting. There we go. Boom. And so this is what happens when you see verbose. You can see that our loss is just decreasing over and over. It's running each training set over 1,000 times. So it's going through our examples that we set up here. So we can see it started with a random value of 400. It just started with a random number, trying to guess what these were. It got that, and after 1,000 hits, it ended with a loss of 0.0016, which is extremely good because it's basically a perfect number. So now if I go up here, we can see basically what it did is it ran over these examples 1,000 times, resetting its memory with training over and over, looking at the examples and making predictions. So once it starts to decrease its loss over time. So now we can actually use this trained model to our advantage. And all we have to write is model.predict. So what we're going to do is we're going to add one more code block. Oh, not there. You can use these arrows actually to bump it down. And also, yeah, right here, before I do that, here's our graph. You can see how high it started at loss when it's at a very low epoch value. But as time went on, you can see as it's stabilized, near 0. And that kind of shows, how the curve looks over time. If I lowered my number of epochs, then we would definitely have a higher amount of loss near the end. But it really, like I said, it's a lot of trial and error between figuring out your learning rate as well as your epoch value. So what we can do is right here in block number 9, we can write print model.predict, and let's just do or sorry, let's do this, 40. If I run that, I get 103.97336. If I actually did the math, 40 Celsius converts into 104 Fahrenheit. So, that's basically 104. So cool, we got that. Now let's actually see the weights that it was able to end up on with the layer variables. So if I just write print, I'm just going to write these are the model's layer variables. And I'm going to add this. And remember, if we use our fancy format thing, we can write layer 0 dot get underscore weights. I can run that. And if you look at that, 1.8 and 31.95. And so, like I said, we got even better value than when I was making this. We got 103.97, which is very close to 104. And so when we look at ours, even here, we got even better values. Just depends on how smart the computer is, I guess, sometimes. But we can see our weights, and we got 1.8 and 32, which match our formula perfectly right here. And so what you can do is you actually potentially build on top of this model by adding more layers and more units, creating a more complex model shape. And I encourage you to go out and look into TensorFlow a bit more based on what you learned today. If you didn't finish, you can always go to stempump.com/r/AI final and find our notebook, which is right here, with all the exact same code that we did today. If you want to skip. We also appreciate it if you would download our app, which is on the App Store, where you can sign up for more camps as well as watch this video and other previous videos and camps, and also read up on all the content available. We'd appreciate it if you'd follow us on social media, on our Discord, Instagram, and Twitter. We're always active on there, so if you have any questions, feel free to ask us. Like I said, this is a pretty complex course, and you probably have a lot of questions. And I'd also love to get your feedback on today's video, since it was actually in replacement of a camp due to technical issues. So you can go to stempump.com/feedback or just scan the QR code right there. But all in all, yeah, thanks for watching the video.